Hey everyone, my name is Kendall. I'm the co-founder of Proximity Labs, and I'm here to talk a little bit about scaling blockchains. If I can get it to, are we? There we go. Scaling blockchains. And NEAR's approaches to doing this and how we are participating in both a monolithic and modular scaling environment. Okay, there we go. So to understand how we are approaching scaling blockchains, let's first touch a little bit on what the bottlenecks are. So there's three major things that blockchains do. The first is that they execute transactions, which basically means when you do a Uniswap transaction, you're swapping from USDC to Ethereum, that computation of the change in your balance is execution. The next thing they do is blockchains store the result of these transactions. And very importantly, they make that new state available when the next round of execution is going to happen. And we call that data availability, which is probably a term you've heard a lot this week and will continue to hear a lot. And the final thing they do is they settle these transactions. And really what this means is you have like validators coming to consensus and ideally providing some kind of guarantees that this state will remain the state until the next block comes in. And you'll hear a lot about finality as part of this. So there's two major approaches to scaling blockchains. The first is, sorry, a little bit delayed on the transitions here. The first is monolithic scaling. And that's basically where you have a single layer one that is responsible for everything. It's responsible for execution, settlement, and data availability. And this is what NEAR has originally been doing. It's also what Solana is doing. So NEAR does this by sharding, which means that you have different sets of validators that are responsible for executing different transactions and storing different parts of state, but then they settle into a single blockchain. Solana takes a different approach where they essentially use increasingly powerful hardware to have all of their validators compute execution, settlement, and provide data availability. And then the other approach to scaling is modular scaling. And this is where you actually split up between potentially multiple L1s, settlement and data availability, and then execution using different layers. This could be layer 2s or even layer 3s. And here are a few of the ways this is split up. So you have Ethereum responsible for settlement and also NEAR. You have Ethereum and NEAR and now Celestia as well, responsible for data availability. And then you have these layer 2s you've probably heard of like Arbitrum, Optimism, and Polygon, who are responsible for execution. What's really interesting about NEAR is that it's actually both monolithic and modular. And what we mean by that is that we are a monolithic blockchain, but we now have products that we're providing to the modular scaling world. So on the monolithic side, and I think what's most interesting, is that we're actually the only chain that's full stack. What we mean by full stack is that you can actually store both your front-end code and your back-end code or your smart contract code on the NEAR blockchain. This is exciting because it means you can maintain maximum throughput for your application with minimal overhead. You don't need to maintain your own validator set. You don't need to run your own sequencer. That's taken care of for you. And then very importantly, this provides you composability across all of the layers of your application. This means your front ends are actually composable, just like your smart contracts are composable with other protocols. So just put up a couple of examples of products that have taken advantage of this. Metapool has decentralized their full stack application, and the OG application for Boss, which is NEAR Social. Now, what's really been different about this week, and what we've been announcing quite a few products in, is how we are offering scalability to the modular world as well. And this is primarily about helping scale Ethereum. So here's a little bit of a look at the NEAR scaling stack, and let's dive in. So on the user layer, we have Boss. The vision here is to unite UIs for various different chains and rollups into single user experiences. In addition to that, we're aiming to make these experiences extremely accessible and resilient. The vision here is to make it so that if you have access to the internet, which means that you can access the NEAR blockchain, then you can access both the front end and the back end for these applications. Decentralized and censorship resistant, that's the vision. And what we recently announced this week as well is this vision of true multi-chain accounts. And very excitingly, this even includes Bitcoin. With this account aggregation product, you will be able to, through your NEAR account, maintain sub-accounts on any ECDSA supported blockchain, which is Bitcoin, most of the EVM world, including Ethereum, and even a lot of Cosmos chains. Moving on to the next layer of the stack, the execution layer. Here's where you probably heard Ilya earlier this week announce the partnership with Polygon. We're working on taking our WebAssembly virtual machine and actually proving it and making it more modular so that various different settlement and DA layers can compose ZK Wasm into a ZK Wasm rollup. And of course, our vision here has always been multiple different options for developers on the execution layer, which is why we have the original Near WebAssembly VM and also the Near EVM that the Aurora team built, and even other virtual machines like a vanilla JavaScript virtual machine. This next layer is also a layer that we announced a new product this past week, which is the data availability layer. So the reason we did this is that data availability costs are actually the single largest expense by far for layer 2 rollups. And excitingly, Near's data availability is 8,000 times cheaper than Ethereum data availability, which completely changes the game for these rollups. They can maintain strong security guarantees by settling to Ethereum, but they can have much, much lower costs for their users. And this is already live on Polygon CDK's testnet, or testnet with Polygon CDK and OPStack, and will be coming to mainnet soon. Now we have the most exciting part, which is the settlement layer. And this is exciting because it's actually the newest product that we've been working on, which is this fast finality settlement layer for rollups. And we've been building this in partnership with the EigenLayer team. What exactly is fast finality? Yeah, very exciting. Great team, super excited to work with them. So what is fast finality? Well, this is going to be the ability for rollups to settle to Near with EigenLayer security guarantees coming from E3 stakers, and then settle to Ethereum. This is exciting because it enables users to transact between layer 2s within 3 seconds, rather than in hours in the case of ZK rollups, or days in the case of optimistic rollups. And extremely importantly, it maintains the full Ethereum security guarantees, and even adds an additional layer with EigenLayer restaker guarantees and Near validator guarantees. And it can be used by rollups with either centralized or decentralized sequencers, so that it's actually up to the rollup team to decide how they want to settle to this chain. So let's walk through exactly how this is going to work. So let's say that we have a Polygon CDK rollup and Arbitrum that are both using the Near fast finality layer. So the Polygon CDK rollup sequencer will submit executed transactions to the Near blockchain. Next, EigenLayer restakers will execute these transactions to check the work of the Polygon sequencer. And they'll get these transactions from the Near blockchain so that they don't have to trust the Polygon sequencer themselves. And they'll choose to either accept or most likely accept, or hopefully not reject those transactions. Then the Arbitrum blockchain will be able to acknowledge that state transition and acknowledge the transaction. And then finally, from the Polygon sequencer, the transactions will be finalized, however long that takes, on the Ethereum blockchain. And again, the real magic here is that this is going to enable actual very, very trust minimized composability between rollups, which really opens up an entirely new design space for applications. So you can think of things like cross rollup swaps at the simplest level, even things like flash loans between rollups, a little more complicated but viable. Asset rebalancing, if there are rates arbitrage you can do between different versions of Aave markets, and then even entirely new classes of rollup agnostic protocols. So to make this a little bit more real, we'll go back to this diagram and walk through kind of a real world use case. So let's imagine that we have a user who has Ethereum on Polygon and wants to deposit into Aave and then borrow USDC. And let's say that the USDC rate is much more favorable on Arbitrum, so they want to get their ETH to Arbitrum in some way and then borrow USDC there so they can get the best rate. So what they'll first do is they'll send their Ethereum to a contract, probably the Aave contract, on the Polygon side. Then the sequencer from Polygon will submit that transaction to Near after it's been executed. EigenLayer stakers will basically recheck the work and then communicate with Arbitrum to let that Aave contract know that the USDC should be credited to the user's account there. And then excitingly, eventually that transaction will be finalized on Ethereum, and the user can actually then withdraw the USDC to mainnet from Arbitrum if they so choose. So this entire process maintains that Ethereum security guarantee. And in the unlikely scenario that there was either EigenLayer restakers or Near validators who are sort of computing incorrect state transitions, then there'll be slashing events, which disincentivizes that type of behavior and should make that scenario never really happen. So zooming out a little bit from all of this, we talked about the different layers that Near is working to scale. How does it all fit together? How do we put this into kind of one thing of like, what is it that NEAR is aiming to do, and why is it that we're trying to scale blockchains this way? For me, I'd say it's really about this idea of chain abstraction. What we're ultimately trying to enable in this very, very multi-rollup, multi-L1, multi-whatever layer you want to say type of world is user experiences that are completely agnostic to which underlying chains are used. Like, users just want to use applications on whatever chain has these applications that are fitting their needs. They want to get the best rates. They want to get the best price execution. They want to buy NFTs that resonate with them, whatever it might be. And then developers want to be able to create these experiences that are as fluent and sane and direct as possible. So here's how it can work. And this is just a very rudimentary graph, but the beginning of what it is that we're trying to do here. Closest to the user, and the main reason we have Boss, is to create this unified user experience. A step below that, we have a similar type of solution, which is this account aggregation and fitting all these accounts together, letting users have a single NEAR account that lets them control their Bitcoin account, their Arbitrum account, Polygon, NEAR account, Ethereum, whatever it might be. A layer below that, we have Arbitrum and Polygon, who are going to need, they're going to need to move this user's assets around so that the user doesn't actually have to think about or take on these extremely long settlement times that'll come from optimistic or ZK rollups. And that's where we have fast finality, so that experience can be seconds rather than hours or days. And really, really interestingly here, and I think the most exciting part, is that every single layer of this stack is going to be powered by NEAR. A user will actually be touching NEAR at multiple different layers of the stack, and developers can plug in to whichever layer is solving their direct problem without having necessarily to take on the entire stack. We will, of course, have these full-stack applications like Ref and Sweat and Mintbase, and we will also have applications like MakerDAO and Aave and Uniswap that will be on rollups that will be using the NEAR fast finality layer and maybe using Boss. So yeah, to wrap it all up, for us, NEAR is about chain abstraction and building and enabling this layer for developers and users to just access whatever it is on the blockchain, wherever it is, without having to worry about moving their assets around or creating new accounts or dealing with any of the complexity that comes with this increasingly fragmented scaling landscape. And that's all I have for you guys today. Thanks, everyone.